Good morning, students. Have a nice day. Today we will see Science and Technology Part 1, Chapter number 6, Refraction of Light. In this chapter, we are going to study topics like refraction of light, laws of refraction, refractive index, and dispersion of light. So let's begin with this chapter. Dear students, we have seen that generally light travels in a straight line. Because of this, if an opaque object lies in its path, a shadow of that object is formed. Opaque means non-transparent object. We have also seen in our previous classes how these shadows change due to the change in relative position of the source of light and the object. But light can bend under some special circumstances, as we will see below in this chapter. Let us see what is refraction of light. For this, we will carry out one small experiment. For this experiment, you will need material like glass, 5 rupees coin, pencil, metallic vessel, etc. Procedure. First, take a transparent glass and fill it with water. 2. Dip some portion of a pencil vertically in water and observe the thickness of the portion of the pencil in water. 3. Now keep the pencil inclined to water surface and observe its thickness. In both the cases, the portion of the pencil inside water appears to be thicker than the portion above water. In the second case, the pencil appears to be broken near the surface of water. Why this happens? One more simple experiment you can perform at your home. Take a 5 rupees coin and keep it in an empty metallic vessel and observe it from the distance. Go away from the vessel, you will find that the coin becomes invisible at certain distance. Now tell your friend to fill the vessel with water and you will see that the coin inside the vessel again becomes visible. Why this happens? In both the above activities, the observed effect are created due to the change in the direction of light while coming out from a water. Light changes its direction when going from one transparent medium to another transparent medium. This is called the refraction of light. Dear students, activity given on page number 73, that is activity number 3. Procedure of this activity, points 1 to 5 are cancelled by the board. So don't study these points, but observation of this activity is there for the study. So let us study the observations. The first refraction occurs when light ray enters the glass from air at N on the side PQ. The second refraction occurs when the light enters air through the glass at point M on side SR. For the first refraction, the angle of incidence is small I, while for the second it is small I1. The angle of refraction at N is small r. Note that small I1 is equal to r. In the second refraction, the angle of refraction is small e, which is equal to small I. On both parallel sides PQ and RS of the glass slab, the change in the direction of light is equal but in opposite direction. Thus, the light ray MD emerging from the glass slab is parallel to the incident ray AN on the side PQ of the slab, but the emergent ray is somewhat displaced with respect to the incident ray. Students, let's learn some questions given on page number 74 of your textbook. First question is, will light travel through a glass slab with the same velocity as it travels in air? Answer is no. Light will not travel with the same speed in the glass slab that it travels in the air. Question 2. Will the velocity of light be same in all media? Answer, the velocity of light will not be same in all media. Next topic is laws of refraction. This is very important topic, so pay attention. Let us study the light ray entering a glass slab from air as shown in the above diagram. Here AN is the incident ray and NB is the refracted ray. First law is incident ray and refracted ray at the point of incidence N are on the opposite sides of the normal to the surface of the slab at that point, that is CD, and the three, that is incident ray, refracted ray and the normal, are in the same plane. Second law, for a given pair of media, here air and glass, the ratio of sin I to sin R is constant. Here I is the angle of incidence and R is the angle of refraction. Sin I upon sin R is equal to constant is equal to N. N is called the refractive index of the second medium with respect to the first medium. This second law is also called Snell's law. A ray incident along the normal I is equal to 0 goes forward in the same direction R is equal to 0. Let us see refractive index. The change in the direction of the light ray while entering different media is different. It is related to the refractive index of the medium. The value of the refractive index is different for different media and also for light of different colors for the same medium. The refractive index of a medium with respect to vacuum is called its absolute refractive index. Refractive index depends upon the velocity of light in the media. Let's see absolute refractive indices of some media. Air 1.0003, ice 1.31, water 1.33, alcohol 1.36, kerosene 1.39. Absolute refractive index. Let the velocity of light in medium 1 be V1 and in medium 2 be V2. The refractive index of the second medium with respect to the first medium 2 and 1 is equal to the ratio of the velocity of light in medium 1 to that in medium 2. So refractive index 2 and 1 is equal to velocity of light in medium 1, that is V1, upon velocity of light in medium 2, that is V2. Similarly, the refractive index of medium 1 with respect to medium 2 is equal to V2 upon V1. If the first medium is vacuum, then the refractive index of medium 2 is called absolute refractive index and it is written as N. Can you tell? Question: if the refractive index of second medium with respect to the first medium is 2 and 1 and that of third medium with respect to the second medium is 3 and 2, what and how much is 3 and 1? Answer is, then 3 and 1 means refractive index of the third medium with respect to the first medium. Its value is 3 and 1 is equal to V1 upon V3. When a light ray passes from a rarer medium to a denser medium, it bends towards the normal. When a light ray passes from a denser medium to a rarer medium, it bends away from the normal. And when a light ray is incident normally at the boundary between two media, it does not change its direction and hence does not get refracted. Thank you, students. Remaining part of this chapter we will complete tomorrow. Till then, take care. Stay home, stay safe. Bye.